So today we're gonna balance some intermediate and difficult chemical equations. And if you can balance these equations, you can balance any equation, to say the least. So let's start. First we have this, which is when potassium reacts with water. So let's count on both sides first. We have a H2O and a K. Here we have a H3 and a OK. So first things we realize that we have to balance the H, the hydrogen. Now, this is even, and no matter what coefficient we add here, H will always be even. So the number of H atoms is always even. Here, this H2 is even, but this H here is odd. So the first thing you want to do is we'll just add a 2 in front of KOH, so that both sides of hydrogen are equal in terms of they are both even. Now if we recount this side again, we have H4 O2 K2. So far it's okay. Now we compare. This side we need a H2, so it's H4. We need an O2. We need an O and we need a K. Right? So simply put, to get one more K, we double the K. To get one more H2 and one more O, we double the H2O. So if I just erase this, that is your final answer for this chemical equation. The next one, let's see. First up, we can already see 3 atoms of carbon and 8 atoms of hydrogen. Here there's only 1, and here there's 2. So firstly, we can easily just put 3C and 4H2. So we get C3 and we get H8. Now if we continue, 3 times O2 is O6, 4 times O is O4. In total, we have a O10. And just if you don't want to get confused, you can just tick off the stuff that you've already balanced. Here we have an O10, and here we have an O2. So we'll have to add a 5 in front. So this becomes a O10. Oxygen with 10, and then it's balanced. Now do note that the next few equations I'm going to go through, even I haven't tried them myself. So I'm going to do it with you guys. So let's start. Now there are brackets, so that means more expansion. Here's Al2, S3, and O6. Sorry, O9. Simple mistakes like that can, make your life a bit more difficult. So after we've done expanding that, we want to see what we can or what should we balance. Now firstly, I can see an Al2 and a normal Al. So when I see that, I'm going to obviously double the Al on this side. So I'm gonna double the Al on this side. Now, as we got that, we have Al2, O6, and H6. Okay, so this is just the O1. Now after that, That's finalized with Na2SO3 and Na and OH. Now we have an S here, just one S, and we have an S3 over here. So again, my first instinct was to add a 3 in front of Na2SO3. So let's see, that's correct. That is correct. So now we have Na6, S3, and O9. Can you see the O9 being a bit familiar? Now so far we can check. Al2, that's done. S3, that's done. O9, that's done. So we've validated this whole part with these adjustments that we have made. Now we have Na6, O6, H6, and here we have Na, O, and H. So this one is the most obvious thing in the world. You just add a 6 in front. So this will be Na6, O6, H6. So there you go, eliminate this whole thing, Na6, O6, H6. So for this question, that's how you do it. Now the next one, I'm gonna see. Let's count on both sides again. With Al2, O3, and Fe. With Fe3, O4, and Al. Now the first thing that I want to do is figure out the O's. With O4 and O3, so we want both of them to have the same number of O's. So the lowest common multiple will be O12. And the easiest way to do this, because there's only one chunk that has an O, the other items do not have an O, so you can simply do a little LCM check. Now to make this O12, we multiply by 4. To make O4 to O12, we multiply by 3. Okay, so far we've done with the O's. And as I said, we did this very easily just because the O's are in their own space. There is an O separated throughout. So you can easily manipulate the O's. So we're gonna rewrite what we have so far. Now there's an Al8 and an Al. So we're gonna add an 8 in front of the Al to balance this out. Therefore, we have an Al8 over here. So let's validate. So Al8, Al8, O12, O12. There's an Fe9 and an Fe. So we add a 9 in front of Fe. This is your answer. Now this one, let's see the next one. Again, I can see O3 and O2, and they're in their own little space. So I'm gonna make both of them O6. O3 to O6 times 2, O2 to O6 times 3. And now, since we've got the O2s or the O6s covered, we can expand this. K2, Cl2, O6. KCl, O6. The O6s are done. We have a K2Cl2 or a KCl2. Or I should put this simply, a 2KCl. And here we only have a 1KCl. So obviously we have to double the KCl. So this little trick of making them the same if they are separated or if they're in their own little space is very helpful. Next one we have is this. So now you can see there's an O here and an O here. So they're not in their own space, they're separated. So we cannot just easily do the trick we were trying to do. We did with the first two or the last two exercises. So let's count again. You have to count both sides. P4, O10, H2O, H3, PO4. Okay. Now, we have a H2 and we have a H3. And they're in their own space. Usually, that would mean I'll make them H6. So if I were to do that, this will be a 2 and this will be a 3. However, when I do this, I'll get an O3 here. I'll get a P2 and an O8. Now, the O8 itself cannot come close to the O10 we have and this O3 we have here. So we cannot just do 3 and 2. Although the H's would match. So that means it must be more than H6. Now what's the next one that they match? H12. So what I'm going to do, I'm going to add a 4 in front of H3PO4. And I'm going to add a 6 in front of H2O. Now, I'm going to check everything again. Because, yeah, checking is good. And here you have faced an example where even though they're separated, the LCM doesn't work. So you have to go to the next multiple. Because even though the H's are balanced, the O's are nowhere balanced. The oxygen molecules are nowhere balanced. The oxygen atoms, they're not balanced at all. So if we check now, we have a P4, O10, H12, O6. You have a H12, P4, O16. The H12s, the P4s, the O10, O6, and that adds up O16. And there you go. The next one, let's see. Is there anything separated? Yes. The ALs are separated. So the first thing I'm going to do is I'm going to double AL. And see if there's anything separated. Then next up we have the H2 separated. But we will double the same value so far. So we'll just check our values first. AL2. H2SO4, Al2, S3O12, H2. So we can firstly mark our ALs as done. And let's see. There's a H2, a H2. We can see, we can mark them, but the S and the O is nowhere done. However, from S to go to S3, we need to multiply by 3. And for the O4 to go to the O12, we also need to multiply by 3. So the right thing to do is to add 3 as the coefficient of H2SO4. As such, we can cancel out this. The H2 here becomes a H6. And as such, we add a 3 in front of H2. So this can also be a H6. That's how you balance this equation. Let's see the next equation. We have NH3 CEO, Cu and CO. We have Cu and N2 and a H2O. Now again, N2 is very separated. And even Cu is separated. We'll focus on N2 first. To balance it, we'll add a 2, and H3. Now after that, the H3 will become a H6. Okay, we'll just do that. So N2 is done, N2 is done, H6, and here we have a H2O. So getting rid of this, we have a H6 and now O3. So our H6 is done. So now we have an O3, and here we have an O. Using the same trick, LCM is 3. We add a 3. So this will be Cu3 and O3. And now the O3s are balanced. But the Cus are not balanced. You have a Cu3 and a normal Cu. So, very simply, we add a 3 as the coefficient of Cu. Now these last two are the most difficult balancing problems we have in this exercise that I'm recording. So let's see, how do we solve this? Again, we're gonna count, and here you realize, are there any more separated? The O's are not separated, and they're all separated, but there's one N here and there's another N here that perhaps we can tap on. Now the main thing in this exercise, or this one, is to fix all the O's. We have a lot of O's. Now we know how the final outcome is that the number of atoms of O's must be a multiple of 3. Because no matter if you multiply by 2, you multiply by 3, ... Number of atoms is multiple of 3 for oxygen, because there's no other oxygen here. It's just an S here. So that's what makes this question a bit unique, to say the least. You have a H2 and a H2. Okay, let's just count first. H2SO4, NO2, H2O, S, and we have a HNO3. Now, first thing I see is there is a H2 and a H2. This is a H4. Now here again, the number of H is always going to be a multiple of 2. Because this is a multiple of 2, and this is a multiple of 2. So the number of H atoms is a multiple of 2. And so we can only multiply this really with multiples of 2. Okay. Now, this is where it gets a bit tricky or confusing. So let's see what is balanced so far. S is definitely balanced. And that's it really. We have a H4 and we have a H3. Oh, we just have a H actually. So you may suggest we multiply this by 4. That can work. Multiply that by 4, N will be 4. Okay. O will be 12. With O4 here, we have O8 here. So here O must be 0. But obviously that is not possible. That's not possible that O is 0. O must be 1. So we can't just multiply it by 4. So that means we have to go to the next one. So can't multiply by 4. Do we multiply it by 6? Yes, we can multiply it by 6. 6 is a multiple of 2. So now what if we multiply by 6? If we multiplied it by 6, we'll have H6 and 6, 18. So now, if we do that, H6. So we have a H2 here and a H2 there. And we need more O's. So we're gonna double this. So we have a H4, O2. Okay, and here you want a 6. So we're N6 and an O12. We have 12, 14, 18. And we have 18 on this side. Let's check again. H6, H2, H4, N6, N6, O18, O4, O12, O2. So is that indeed the answer? Let's check. So 6 is here. 6 is there. And 2 is here. So this is definitely a more thinking question, where you need to realize that, oh, some must be multiples of 2. Some must be multiples of 3. So there is the difficulty or the standard that you need for this question. Now, the last question, presumably the most difficult, we have a CU, a HNO3, a CU, NO3, 2, which I'm going to expand out, N2O6, NO, H2O. So I'm seeing that there's a H2 and that's just a H. So perhaps I would like to double this. Perhaps I like to double it. Here O3. So we know again that number of O's is going to be a multiple of 3. It's going to be a multiple of 3. So number of O's will be a multiple of 3, no matter what you multiply with it. So here we have a O6, multiple of 3. And so you have, it can be like a 1, 2, so on. Or they can both just be multiples of 3. Both of them. So that depends. CU N2 NO. Here we have O3, we have O6, O so here together O8, then O3. Now we are going this O8 and multiple. Now for this kind of question, you can see there's no obvious way of what to do. So really, you have to just test. You have to test what to do. So first you're going to test, because I have a H here and a H here. I'm going to test if this is 2. I'm going to test. You have a H2, an N2, and an O6. Okay. Here we have a CU, N2, O6. So far looks perfect. But you realize that there is 2 more extra oxygen over here. So in fact, I'm not gonna have to multiply by 2. I'm gonna have to multiply by more, perhaps 3. H2 and H2. The next one can be 4 as our least common multiple, the next multiple. So let's try multiplying this by 4. Okay, so let's try multiplying it by 4, for example. So if we multiply by 4, just gonna give me some space real quick. If we multiply this by 4, that means we have to multiply this by 2. But we'll check here. We have a H4, an N4, an O12. Here we have a Cu, N2, O6, NO, and here we have a H4O2. The H4 is matched. Okay. O12. We need an O12. So, and also the N2 here. We need it to be an N4, so to double this. Well, if he's double that, that's O12 already. And we still have O2 and an O. So that is a bit troubling, right? We have more O's on this side. That means we have to continuously increase the number. So make this 6 and we'll make this 3. So here we have H6 and 6, O18. Okay, so far that looks all right. Actually, I may have made a mistake with the earlier one. Check 4, right? Yeah, okay, so N2, we can, yeah, I think I did make a mistake. Yeah, I definitely made a mistake. Sorry. Let's just check this again, because I'm worried that I made a mistake. So this is 2. That'll be H2, N2, O6, Cu, N2, O6. Okay, so 2 is impossible. We have 4. And 2 over here. So H4, N4, O12, Cu, N2, O6, H4, O2. So we need 4. So N4, O4. Is that the answer? I'm not too certain. I don't think that's the answer. Yeah, no. Which is interesting. What are we missing? 4 and 4, O12. 2, so H4O2. O6, O4, O2. This can work, I think. I don't know what's happening here? N2, O3, that is correct. 4 and also N4, O4. Ah, I see, yeah, so this can only be 2, but in that case, we are short of 2 oxygen molecules. So again, 4 is impossible. So guess what? We'll have to increase it again to 6. So that's H6, O6, sorry, N6, O18. Here's again C2, O6, 6, so this is 3, so H6, O3, 9, so this needs to be 9 if you don't want to change the other one, but and 9 obviously cannot, and 6, the most we can go is 4, so no. Perhaps you can double this too, so we have N4 here and O12 here, but then here you need a 3, but the max you need is a 2, so yeah, even 6 cannot. So just going in a whole checking phase for each one. So let's try 8. The only reason they're difficult is because I guess they're kind of annoying to solve. So here I need a 4, so H8, O4. Here normally you'll see N2, O6, and O. So O4 we need 20. We need 20, yeah. So I guess I can N8. We can double this. That will give us Cu2, N4, and O12. And then we can N4. We need 4 of this. So we have N4, O4. So the oxygen 24. This is not 24. It's not 24 yet. So it's not 24 yet. So we need an increase. And we need an increase in the number of oxygen. So instead of that, we are gonna multiply this by 3. So we see 3 and 6 and O12. Not 12, 18. There you go. And then here we'll multiply by 2 and 2, 2. We check H8, N8, O24, 18, 2, 4, Cu3. So we need a 3 here. We need a 3 here. So 3 here, 8 here, 3 here, 4 here, 2 here. There you go. That should be our answer. 8 here, 3 here, 2 here, 4 here. So as you can see, this is very hard because you have to go through every single type of combination. And even I took some time of it, as I said, from question 3 onwards, I did not try these questions. I only tried the first 2 questions before preparing for this video. So yeah, these are the more intermediate or difficult kinds of questions. So if you manage to solve all these, or you manage to understand what I'm doing, you should be on the right track on balancing chemical equations. So thank you.